Awesome.
Right.
Yes,
Welcome,
okay, looks like it's
everyone.
coming
Yeah,
through. Mhm. Yeah,
wonderful.
let's get started.
So, yeah, we haven't really announced any topic for this call, and the purpose of this call is really to have this technical brainstorming or announcement or knowledge sharing as we like resolve issues, introduce new features, or like figure out some technology advances. We want to use them in the Cloudline ecosystem to enable a lot of interesting use cases. So really, this is a knowledge sharing place for developers, and we try to make it up to date as much as possible. So I want to use this forum as a surprise call today to share some topic that could be relevant to all of you as well. So to give you guys a little context, so we help a lot of tokenized communities and a lot of members to do this token gating. And toward the end, the token gating logic is really say, hey, for a given member, say you're coming from Telegram or you're coming from Discord, right? You join Cloudline by connecting your wallet with Cloudline. Then Cloudline has a knowledge about what wallet you have. Then from the community admin perspective, that define the token gating roles that utilize the different type of digital assets, especially the on-chain assets such as a fungible token or non-fungible token. Then really the qualification becomes a matchmaking process, right? So say, hey, for a given user, let me kind of just introduce some of the personas here. So let's assume we have a user, and of course now we support multiple wallets per user for one community. So that means there's a possibility you could have multiple wallets, right? Then for a given community, let's say we get a community into the picture, and still you have a community here, but I don't have a very nice icon here. So just pick a random one. Like say we have a BAYC community, right? And this community admin decide to say, hey, we try to grant different roles to our members based upon their ownership of this ERC 721 smart contract. And let's use the BAYC as an example, right? So I want to kind of use this use case to really help you understand how we do balance check and how we interact the small contracts on the blockchain. So the main purpose is try to convey some interesting techniques we use to significantly reduce the RPC cost. And I'm going to kind of explain why that becomes an issue and how do we find an interesting way to have a significant reduction of the RPC cost and also improve the speed of the balance check. To just walk through one simple use case, let's say we have a BAYC Discord server and they decide to create different rules using the BAYC NFT contract as a source of truth. So before Cloudline, in 2 years, initially we only allow the balance to be used for token gating, meaning, hey, as a member, if you own one BAYC, you get one row. If you own two BAYC, you get another row. So that was very much the quantity-based check. And for the quantity-based check to happen, it's fairly straightforward. Like say, between a community and a user, we say, okay, for the user, we have wallet 1 and wallet 2. And basically, we go to the small contract, say, hey, let's use the user's wallet address as an input to call this balance of API call. Right? So balance of basically tells how many NFTs that given user has on this contract. Right? And if you don't care about all the information and you only care about the quantity, then that's it. So we very much make one call to the balance of per wallet. If the user have multiple wallet, then we have to call that multiple times. That also depends on how many rules you have here. Right? So you might have one rule for one token, two rules for another token. Then we have to make that call by the number of rules as well. So for the quantity-based approach, it's not very heavy because very much we make a, theoretically speaking, one RPC call, you can get that information, right? So I can also show you from the Etherscan perspective, say, hey, you basically go to the smart contract. So this is a smart contract for BAYC. Then from the smart contract perspective, you can click on these contract tabs. Then from the contract tab, you can click on this read contract, because for us, it's a read-only access to the smart contract. Then you're finding the corresponding methods from the ERC 721 standard. So the first one is balance of. And I just get some random address that has a lot of BAYC tokens. So I can just run a query and say, okay, how many BAYC NFTs this address own? So it turns out that's 300. Right? So for a typical quantity-based token gating, so that's the end of the story, right? But since we introduce, the advanced features such as allowing multiple wallets per member, and also allow the NFT attribute to be a source to choose for token gating. So that introduced the complexity quite a bit. And as a result, like we see a lot of pressure from the infrastructure side, and we pay a lot of money to the blockchain RPC providers. So to give you a number, like very much before this optimization, we had to make about 50 million calls to RPC providers each 24 hours for mainnet only. Then any other blockchains, that's almost like a 100 million calls per day. So that's a huge number, and we pay a heavy price to cover the community. And we basically say, hey, that's not going to be sustainable. So what we can do about that? So we kind of dig into the past and try to understand for each of the token gating rule enforcement, how do that translate into the lower level API call? For example, we use Ethers.js as the JavaScript SDK to interact with a lot of smart contracts. And Ethers.js give us some tracking capability. So we can kind of tell what are the API calls that are being made onto the RPC provider. And we also look at the dashboard from our RPC provider and say, what's the breakdown of the different calls? Okay. So we find out there's some interesting data, and one, concrete path would be kind of described in this diagram. So imagine we define a token gating rule for BAYC and say, hey, for any BAYC, depending on the different treat the NFT have, you could assign a member with a different role, right? And to enforce that, the complexity increased significantly, because not only we have to make a balance of call as a starting point, one thing to add here is a lot of smart contracts are implemented and designed for on-chain transactions. So they don't pay much attention for the different view methods that help the community to understand the ownership, right? So sometimes it's a bit tricky and heavy and not very optimized to understand for a given wallet, how many tokens they own on a smart contract, and what are the different token IDs for each of the balance they have. And then for each token, usually there's a so-called token URI, and that token URI will point to an IPFS URI, and then we have to resolve the IPFS URL to understand the metadata behind each of the tokens. Okay, so that's just how the smart contract I designed. They're kind of very optimized for the on-chain transaction, but they're not really friendly for queries. So that's where the overhead comes in. So for example, if we have to implement a token rule that expect to use the attribute of a particular token ownership to decide which disco role you will be qualified to, So that will translate into multiple steps. So again, the first step is like we identify the user. Then from the user, we identify the wallet address. Then from the wallet address, we first call the balance off. Right? So that's already been shown here. Say, hey, for this wallet address, we call this balance off call. Then we get the balance for this wallet. But we don't have enough information to make a call up to this point because we only know how many tokens that wallet owns, but we don't have any information about the different token IDs and what's the metadata behind each of the token ID. Okay, so that means we have to continue to make other API calls, and the next call we have to make is kind of iterate through all the balance index. Then we try to say, hey, what token ID maps to each of the index, right? So that's why we have to make a second call, which is this token of owner by index, and we know we have 300 tokens, right? So the index by the owner will be from 0 to 2999, right? But we still give the owner address here and say, hey, what's the first token ID? So in this case, we give the index 0, then we get a 4144 back. But if we change it to 1, then we're getting back a different token ID, right? So this implies we have to make for this user, because we know this user have 300 tokens, right? So that means we have to make at least 300 RPC calls to these view methods, index by index from 0 to 299, right? So up to this point, we make one call to the balance off, then we make 300 calls to the token of owner by index, right? So that will become like a 301 API calls to the RPC provider. But again, this is still not good enough, because once we finish this first batch of 300 calls, what do we have? We basically getting back a list of token IDs, right? So the token ID is just a number, and it does not have any, attribute around the token ID. So what do? So we have a next step to be involved here. So for the typical ERC 721, there's another method called token URI, right? And the token URI takes the token ID. So let's kind of go into that token URI. So we already look at the first token, which is 4144. Then if you click on the query, you're getting back this URI, right? And this URI, it's really the IPFS URI. And then we sort of have to resolve this IPFS. Then we can actually get the, JSON metadata behind this, URI, right? So here it's like say, hey, now we load up all the attributes for this particular token ID, and there's certain trait types. Hey, if you want to qualify a role by the background, then you sort of have to say, oh, background equals to blue, or you have a different fur or different clothes or different eyes. So finally, we finding the metadata for one token ID, right? Again, we need to find all the URIs between all the token IDs that wallet owns. That means we continuously invoke the token URI view method call 300 times, right? And not saying once we get a token URI, we have to pay the IPFS provider to retrieve the IPFS metadata, right? So that means we also have to do that 300 times, right? So rule is very typical, right? And it kind of looks fairly straightforward on the surface. But if you have to implement the background check by interacting with the smart contract behind that NFT token, then now we translate one wallet into 1 plus 300, and the plus another 300 calls, Then we process another 300 calls to IPFS. So that's almost like 1,000 calls. We have to just do one balance check for one user for one wallet, right? And imagine if the user has 3 wallets, then will become 3,000. Then also, if the community have multiple rules, like say they have 5 rules, that's this 3 wallet times 3,000. 3 wallet times 1,000 times 5. That's a lot, right? So that's why we see significant increase from our infrastructure expense. So what can we do with that? So one typical technique to minimize this, 1 to many call is to do the server side join, but the blockchain does not have that ability, right? So the smart contract for ERC 721 does not even have a batch method. So basically, they don't have a batch method to retrieve like multiple token URIs in one batch. They don't have a batch method to get all the token IDs by the wallet or by the indexes, right? So the smart contract is just not friendly for query, right? So how do we minimize the impact and find an interesting way to optimize that? So we understand like all the costs we are making here, it's very much like a read-only cost, right? So we are not carrying on a transaction. We basically just call the view methods and get some state out of the blockchain to help us understand the ownership so that we can meaningfully enforce the token getting rules. So one technique we figure out is there's something called multi-core contract. So I kind of point some of the multi-core contract. So somebody can deploy a multi-core contract to a given smart, a blockchain. And the purpose of this contract is to aggregation. So it kind of say, hey, you can make a multiple view methods call and pass that in as a array of arguments. Then for each of the core object itself, we put all the information into that structure. So for example, here, when we talk about each API call, RPC call, right? You say, hey, if you have to call this smart contract with this, encoded code data, you can encapsulate that request into a structure. Then when you interact with this facade contract, you basically passing an array of these wrappers, right? Then inside the logic, what we do is, hey, let's kind of just split this multiple calls. Then we use the target, which is pointing to the different smart contract, even though in our case, this target will point to the same BAYC NFT, right? But we use a different methods, like say we call the token ID by owner index 300 times. But instead of calling them 300 times, we can construct 300 calls and passing that 300 calls into this one single method, right? Then we basically say, hey, once we make that call, we get a result back from another contract. So we basically say, hey, so if I have to draw that, right? So I basically say, hey, let's introduce another layer, which is the multi-call smart contract. Okay, so you have this multi-call smart contract, and there's a bunch of aggregate method, which takes an array of call object, right? So you do it this way. Then very much all the RPC call, instead of going to the smart contract directly one by one, we basically say, hey, let's just construct a bunch of different calls. Like say we do, just use this method, right? So we do this way. So we have this call here, and say the first one is passing argument 0, right? And then we keep adding these calls into this array. So we will have, by 1 and all the way to by 299, right? So this whole thing becomes an array argument. Then from collaborative perspective, we basically just passing this whole array to this smart contract, right? And that means we have a call from here to here, right? Then the logic inside this aggregate method will basically say, hey, let's make a call to the different target because each of the call methods, we have the NFT smart contracts, not only just the method signature with the real arguments, but we also have this BAYC smart contract as a target of that call. So this array of structs passing to here, then internally, this facade contract becomes our batcher, right? So this facade contract will, making a loop and calling the smart contract, then aggregate result into an array so that we can basically implement a batch from this technique, right? Then once we have the batch result back, we can pretty much know, okay, index by index, that's a result to simulate, to replace the 300 calls we have to make for one wallet, right? So all of a sudden, we reduce this, 300 calls into one call because the creation of this input into an array is happening on our backend. Right? It does not incur any cost from the RPC perspective. Then we kind of say, hey, let's use the RPC provider to make a real method call into this facade contract. Then we have the facade contract to do the heavy lifting job to interact with. And then what's interesting is on the blockchain, whenever you call a view method, you don't have to pay gas, right? So there's not much cost associated with this loop. It just takes a little bit of time. Then when we interact with a RPC provider, now all of a sudden these 300 RPC calls get reduced to 1, right? And of course that could be iteratively applied to any other methods. So that means in this whole flow, we first make one RPC call to get balance off. Then we make this batch call to get all the token IDs for this particular wallet, right? Then with the token IDs, then we can construct another call, which is a token URI. And from the token URI perspective, you basically just construct the different token IDs as an argument for the token URI, right? So that means this 300 plus 300 becomes 1 plus 1, right? So that's almost like 600x reduction. Depends on the wallet. If the wallet have 300 tokens, then we get saving of 600x. If the wallet have 5 tokens, then we get a 5x thing, right? So then once we have the token UIs, then we will further optimize. So we haven't implemented that yet, but we can also look at the possibility how we can retrieve this different, IPFS, content from the IPFS provider. So at least from the RPC perspective, we reduce from this, almost like 600 calls into 3 calls, right? So that's kind of very significant. Yeah, so that's kind of the main topic, and of course, I only use the ERC 721 as a walkthrough, but it also equally apply to ERC 11555, right? Especially for a lot of NFTs that's minted from the OpenSea smart contract, and that's a very heavy ERC 1155 smart contract, and supporting so many different token IDs and supporting this balance for each of the wallet. We get a very nice reduction from there. Another interesting thing is this facade can actually handle quite a bit number of arguments. So I think like for the moment we use like a 1,000 calls in one batch, and from our backend perspective, we can break down the number of arguments into different groups. Right. So say you have 10,000 tokens. Then how do we do that? So we first break the 10,000 tokens into a group of 1,000 tokens. So we end up have 10 different groups, right? Then we basically make a concurrent call to this facade contract. We pass to the first 1,000, second 1,000, but we have the ability to make them in parallel. So we basically just getting this, 10,000 tokens in pages. It's kind of like the pagination, right? So we deal with first page, second page, but we can actually deal all the pages you want concurrent requests. So that also help us to decide what's the threshold, like how many batch items we can put into one batch to not incur enough gas fee to revert the RPC call. Right. So those are the tricks we use. And of course, if you understand the problem and this technique doesn't seem to be very fancy, it just works. And the way we kind of troubleshoot these infrastructure issues is we first look at the data points. We look at the dashboard. We tracking down the problem by understanding the call graph, right? So we kind of go from the high level, because from the high level perspective, it's like saying, hey, one community have multiple rules. And of course, there are different rules, and the rules are pointing to different assets, and they have a different expectation. Some of them requires metadata, some of them does not require metadata. Right? And we try to optimize for the different cases. For example, if you don't care about the metadata, we don't even bother to call these 2 additional or 3 additional API calls. Right? If you do have to require metadata, then of course you need to go through this. Right? Then we also try to translate the technical stack that from the product perspective, you are really doing a check for each of the wallet from the member against the different rules set by the community. But this translates into some technical stack and ultimately translate to some RPC call. So we have to do some work to pass down this context so that we can understand who's the heavy consumer, right? So in that context, we'll have information about what's the community ID, what's the user ID, what's the wallet, and we even have the information about what's the rule itself, right? So this way, every single RPC call, we find the ultimate consumer, right? Then that gives us enough insights to understand why this translates to so many RPC calls. Then how do we optimize that? Right. So that kind of leads the discovery to say, hey, basically like we're kind of have 1,000 cards for every single balance check, and that translates a lot of infrastructure overhead and a lot of expenses to pay the RPC provider. So with this simple technique, we were able to reduce a huge number of RPC costs. So we push this optimization a couple of days ago, and we see almost like 3 quarters of reduction. So that means we pretty much cut from like 100 million calls per day into about like 25 million calls per day across all the different blockchains. Right, so that's huge. I want to pause here and see if there's any questions from the audience.
So I'm reading the chat, and there's no questions as of the moment. But there's one comment that I wanted to bring up, saying this is super awesome, Raymond, saving a lot of resources and computation.
I appreciate that comment. and we always try to identify opportunities to really make the system operation in such a optimized way. And for Collabline, we have a lot of upstream dependencies. Right, we have to utilize the RPC provider. We need to work with some push notification service. We call Discord API, Telegram API, OpenSea APIs, and also depend on the different rules we have. We might have to call Twitter API, call some GraphQL APIs, and one of the biggest challenge we have is some of the service providers do have a written limiting. How do we make sure we serve so many tokenized community and don't go over the limiting? So we have to put a lot of effort to make sure we coordinate on the client side to respect the limits imposed by the service providers. And meanwhile, every single service provider call potentially can incur some cost, not to say the cost associated with our cloud provider to have this computational memory requirement, but also like for some of the service providers, especially the RPC provider, it is only cost monthly for us. Right? So we kind of continue to optimize the system and find an interesting way to optimize. So that's just our mission, and that's why we want to share these findings with the community to give more insights, and also there's a possibility you can apply similar tricks in your own applications in the future. That being said, we'll also add a little bit of color here, because people can claim they can do token gating, right? When it comes to the skill we have at Collabline level, we support so many different wallets. We support so many different kind of rules. We support so many different, blockchain connectivity. Then we even explain from our blockchain capability to off-chain, digital assets, such as your Twitter profile, such as your verified information. So those are very interesting knowledge base. And I think moving forward, we are trying to figure out how we can meaningfully create a ownership friendly view of the blockchain. And of course, there are a lot of indexing services available on the blockchain today, but they're just shooting the dart, right? So they just index every single data and hope somebody find that useful. But from the ownership perspective, how do we surface that data so that any single wallet provider or any token gating service or any other community, they can have this holistic view about the portfolios of the digital assets under the authorization of the user? So that's quite interesting, because that's what we are doing here. And we solve that problem today by interacting with the blockchain and looking at other oracles to get that information. But I think moving forward, we might want to dive into that area and see how we can meaningfully create a valuable knowledge base about ownership. Okay? Then with that ownership knowledge base, then we can even add artificial intelligence on top of that knowledge base and open that up to the crypto users and the community, so that they can get deep insights from that, and also have an easy way to understand the ownership instead of forcing each of them to do the same heavy stack as we are doing here, to translate or map the different queries into different infrastructure we have to deal with. Okay. So that's kind of on our radar, and see how we can meaningfully create a very ownership-oriented view of the digital assets, and even adding additional dimension to that view, because oftentimes this ownership as a snapshot, right? But similar as the credit history, you don't only look at the snapshot, right? So you want to look at the reputational progress you made and how much engagement you have over time. So that means the timestamp dimension to turn these different views into a time series database, right? So then not only you can see the snapshot of the ownership, but also you can see the change of the ownership over time. Very much like when you come on board from Web 2 to Web 3, you start to get your wallet, you get some assets, or then you get NFT jobs or like ERC-20 jobs. So the more engagement you have, the more digital assets you have. For example, if you attend these calls, you receive the POP, right? So those are the digital assets you accumulate. But understanding this, digital asset portfolio over time could be also very interesting. Then between the different owners, there could be connections, right? Say, if you own BLYC and other people own BLYC, this the intersection could become an interesting dimension as well to help to understand how the community are being built around the different members, and do these members from the same NFT community share the same interests from their portfolio, right? So those are kind of a little bit future looking, and we will continue to explore the different opportunities to understand this ownership graph from the blockchain and go beyond the blockchain to include the off-chain states such as the verifiable credentials and the social profiles and some other knowledge that not strictly available from the blockchain, and have that aggregated knowledge base will be pretty meaningful. So we kind of look forward to have further advance from that angle as well. I think that's all the material I have here. Hopefully this technique could be helpful. And so we are in this world, like you need to be very creative to interact with the blockchain. So we are talking about this read-only operation. Then we pay the RPC cost. But when you start to do transactions, then you also run into the challenge like how do you save the gas? Right? How do you put a lot of steps into one atomic transaction? So there's another interesting challenge like how you can meaningfully batch the transactions. If the smart contract supports it, that's great. If the smart contract does not support it, what can you do? Okay. So there's some solutions available. For example, you can utilize those safe. Then you have to transfer the assets into those safe smart contracts. But I think with the emergence of the ERC 4337 smart contract, then there's much more flexibility. You can actually interact with the smart contract directly instead of interact with the EOA. So EOA kind of shifts its responsibility. So the EOA will become the signer, then the smart contract will be the asset holder. And since everything is owned by a smart contract, then there's much more flexibility. You can actually batch transactions together in one user operation or in one transaction. So that's quite exciting as well. All right, a lot of talk from my side, and I want to conclude here. And Chibi, if you can double check again and see if there's any questions from the chat. And also, maybe it's a good time to start to distribute the pod.
Yes, that sounds great. I wrote it in the chat, but just to bring it up again, if you guys have any questions, please feel free to drop them in the chat, or you can raise your hand and we'll bring you up in the stage. Also, if you are watching this recording in the future, because this is being streamed to YouTube and Twitter as well. If you happen to see this in the future and you have any questions, also feel free to bring them up in any future dev deep dives, or you can write them in the dev general chat. Both of those would be perfect. So, having said that, we'll keep looking at the chat to see if there's any questions. But in the meantime, let's get to the POAP. And in order to claim today's POAP, as usual, we'll be using the POAP mini app. Very easy process. You can use the command here in the state chat or the general chat. Should work in any of those. And the command that we'll be using to claim the POAP is /POAP claim. I will also make it easier by sending a command in the state chat that you can just click and it should work for you to use the command. And then you'll see that it asks for a secret phrase. And today's secret phrase is collab call. All lowercase and with no spaces in between. Collab call. That be spelled as COLLAB CALL. Collab call. Again, all lowercase and with no spaces in between. Once that you write that down, hit enter and you'll receive a code to claim your POAP. Oh, it looks like it didn't work for James. You need to wait for the prompt when you write down the POAP claim before clicking it. Yeah, once again, just in case, /POAP claim. And then the secret phrase is collab call. Please let us know if it's working for you. And if it isn't for any reason, that's okay. You can let me know and I'll send you a code for you to claim the POAP. Did you claim yours yet, Raymond?
Yes.
Awesome. All right, looks like everyone in the chat was able to claim as well. Thank you guys for letting us know. I love the colors for this one. I think they're very cute. Jerry, awesome. Looks like everyone claimed successfully. Thank you so much, guys, for claiming and for joining today's Dev Deep Dives. With that, I think that we are ready to wrap things up. What do you think, Raymond?
Yeah, that sounds good. And again, thank you for attending. And we try to make this deep dive meaningful and up-to-date days. So that's why we share all the technical demands or major feature or even small tips and the tricks in this forum and make them available for watching later. Yeah, see you next time.
Thank you so much, Raymond. Just to remind everyone, our Dev Deep Dives happen every 2 weeks. So our next one would be on September 27th, just so that you are all aware. And of course, you're all invited. Thanks again, everyone, for joining. We will see you guys next time. Bye-bye.
Bye.